everybody, it's lesson 17 with Miss Phoebus, basic algebraic functions. And so these functions are ones that we are going to experience quite a bit. There are four that are like the main focus, but then there are four more that you could run into, and there are actually others, but I don't want to give you too many. So there's eight basic algebraic functions. So what I need you to do is I need you to set up on your notebook paper, you're going to create a coordinate plane. You are going to need 8 of them, but you also need some space to be able to do like domain and range, and I'm going to have all of that stuff broken down, what the family name is, all of that. So our functions are going to be in families, and I'll talk about that in a little bit. But you can go ahead and set up your notes to where you have a coordinate plane that's blank, you have some space next to that, and you need 8 of those. One of the other things that I highly recommend doing is maybe having a marker or something of a different color close by, so then that way when you draw the actual function, it kind of pops out from and looks different from the coordinate plane. So that's just something that I think is helpful. We are going to identify the domain and range of functions on the coordinate plane. We're going to write them in interval notation just because that's my favorite, but you should be familiar with the set notation. We're going to identify function types based on the basic shapes of their graph, and we're going to use the graphing calculator to graph algebraic functions. So that's exciting. You have a graphing calculator on your Chromebook. It's a TI-84. And if you don't know how to access it, you need to email me. I can walk you through it, but I'm going to have my own. It's going to look a little bit different that I pull up, but it should be relatively the same. So it's got a different look, a different feel to it, but it's the same buttons. We're still looking at domain and range, but we're also introducing all these functions. So if you look at some of the other standards, you need to be able to identify key features of different kinds of graphs that are quadratic, linear, absolute value. So you have to know and be introduced to all of them. So instead of writing every single one of those standards out, just know that we're going to look in depth at several standards that have these different functions in them that you're required to know and be familiar with. So, and then you're also still looking at domain and range. Okay, so remember your 8 little graphs? The first 4 are the main 4 families for Algebra 1. When you get to Algebra 2, Pre-Cal, Calculus, you get some new function families. But these are the main 4, and then I'm going to introduce 4 more that you will also see. So the first one you've already been introduced with, it's linear. So put a point at 0, 0. And we're going to do just kind of a positive slope. That is your linear function. Its equation is going to be y equals x, or if you're looking at terms of f of x, remember f of x means y, f of x equals x. So I can replace y with f of x. Those are the same thing. So as long as you have an x to the first power, and that is the only x that's there, then you have a linear function. All right, let's look at the domain. So how far left can this function go? It goes to negative infinity. Negative infinity gets a parenthesis. How far right does this function go? It goes to positive infinity. Positive infinity gets a parenthesis. Now this is true for every linear function. The domain of every linear function is negative infinity to positive infinity. That's just how their family works. The range, how far down this family goes, is negative infinity. How far up this line goes, it goes up to positive infinity, and that's true for every linear function. They have the same domain, the same range. As soon as you cut it, you stop it, you make it do something different, then it's no longer linear family. All right, let's get our second family, the absolute value family. So the absolute value family has an absolute value in the equation. So you can write it as y equals the absolute value of x Or if you pull out the f of x stuff, f of x equals the absolute value of x. Those are the same thing. And here's what the graph looks like. I want you to go to 0, 0, put a point. And then you're going to kind of do up and to the right for the, like what we did for the linear. But on the other side, you go and you make a V. V for value, absolute value. That's how I remember it. All right, domain. How far left? Well, it can go to negative infinity, comma. How far right? It goes to positive infinity, and there are parentheses around each one. Now, this one's different for the range, but domain for every absolute value function is negative infinity to positive infinity. Now, for your range, if you notice, there is a lowest value. It's like you come through, you stop, and then you go back up. So there is a lowest point. And at this point, it's 0. So we're going to write from 0, gets a bracket, lowest point, comma. How far up does it go? To infinity. Now this is going to change from absolute value function to absolute value function. So if I drop this absolute value down 3, I've changed its range. If I shift it up 5, I've changed its range. We're going to talk about that later. But right now, for this graph that I just drew, is our range. Now, what we're going to do is I'm going to show you how to in the graphing calculator. All right, so I've pulled up my graphing calculator, and I'm actually going to show you these two at a time. So I'm going to show you the linear, how to graph that, and I'm also going to show you the absolute value, how to graph that. You can have the video in one window, and you can have the calculator in another window, and you can hit the Alt-Tab button to kind of those keys to go between the two windows, so you can go back and forth and watch, pause the video, you go try it. So in order to graph things on a graphing calculator, you need to use the y equals button. So this button is always the button that you use when you graph. All right, so I'm going to hit y equals, and what that does is that pulls up, basically it's 9 different spaces where I think it's 9, oh, there's 10 different graphs that I can make all at once. What we're going to do is we're going to graph the linear function x. So for the linear function, as well as any function, you could hit the alpha and then go find the x, but this is the x button. Now it has other letters on there. It has a T, it has a, looks like a 0 wearing a belt. That's a Greek letter. Theta, it has a little lowercase letter n. The T, the theta, and the n, you don't have to worry about because they only show up when you are dealing with it being in a different mode. So you don't have to worry about that. So we're just going to click X. So we basically have y equals x. This is our linear function. And if you would then hit the graph button, then you're going to be able to see a picture of what that function looks like. And then if you hit second, which is the blue button, and graph, then you would see a table. So there's, remember where I was like, hey, you need to make a table of values. Look here, it's made a table of values for us, and we could use that to help us graph. All right, I'm going to go back to y equals. I'm going to clear out my x, and now I'm going to do the absolute value of x. So to get to the absolute value, to graph the absolute value of x, there's a couple ways to do it. You can go to, there's 2 ways. So math, and then you go right to num, and ABS is abs. You could do it that way. Or you could go back to y equals. You got to be in y equals in order to graph. You can hit the green alpha button and then the window button. And there's abs right there. And that's the one that I'm going to choose. Inside abs, I have to put something. And if you're not graphing a variable, you're only graphing numbers, you're not going to get a right graph. So you need to have a variable in there. If you needed to add something inside the absolute value, you could. You see the little flashing black and white arrow? That means that if you want to add anything after it, you can, but you have to hit the right button in order to be able to get outside those absolute value bars. Let's go ahead and graph it. So we're going to hit the graph button. And there it is. There's our absolute value v. Now it looks kind of squished. If you notice that the distance on the x looks a little bit larger than the distance of the intervals on the y, that's why it looks a little bit squished. You can do a table, so you hit second graph, and there's a table of values for you. So if you wanted to actually graph this on your paper and use the graphing calculator to help you plot points, that's what you do. That's what I would recommend doing, especially if you're having trouble graphing things. You can always rely on the graphing calculator. Now, when we get to the end of course test, there is a portion of the test that you're not allowed to use a graphing calculator on. It's usually over 3 days. One day you're not allowed to use a graphing calculator or a calculator of any kind, and then the other 2 days you are allowed to use a calculator. So you should know how to be able to read these functions and identify them without a calculator, looking at their shape and things like that. All right, let's go and do 2 more and then we'll come back to the calculator. So our next function family is the quadratic function. Y equals x squared as its equation, or if you are playing with f of x equals x squared. But this is where your x is not to the first power, it's to the second power. And so we're going to go and graph it. We're going to put a point at 0, 0. And this is a curvy. So absolute value was a V. This is more of a U shape. So we want it to have arms to the right and to the left, but we don't want them to be straight absolute value V arms. And you do have symmetry. Absolute value, you also have symmetry, so the left arm and the right arm should be doing the same thing. This one's not. My right arm's having, or my left arm's having some issues. Let's see if I can make it look better, more symmetric. This is better. Anyway, right now you're not plotting points. So if you are going to have to graph anything, you're doing just a basic, this is where it is kind of graph. And we'll talk more about that when we get into transforming functions. All right, domain, how far left, how far right? Domain is from negative infinity to positive infinity. It goes left forever, it goes right forever. The range, though, this is like the absolute value. There is a lowest point. The lowest point is 0, so we're going to go from 0 to positive infinity because it goes up forever. So again, your range is going to change. Ew, look, I'm a poet and I didn't know it. Your range will change as your function changes. So if I drop this down to like -4, then it will go from -4 to infinity. If I pick it up and shift it up 1, it'll go from 1 to infinity. So I will be, as my function moves around, I will be changing its range, not its domain. Every quadratic has a domain from negative infinity to positive infinity. All right, here's the last of the 4 that we have to talk about. So the exponential function family, they don't fit into the idea of, they have to have limits, basically. They have to have something holding them back. So we'll talk about that in a second. So we've got y equals, and I'm going to go simple here. When we actually talk about exponential functions, we're going to go a little bit more in depth. But we're going to use b, and we're going to raise it to the x power. And it's exponential. That's the name of the family because the x is in the exponent. The x is in the exponent. That makes it exponential. All right, or we can throw f of x in there and have b to the x. Now, like I said, later on, we'll get fancier with these guys. They'll be doing more things. They'll be doing some interesting things. But let's look at graphing these. And when we graph these, think that there is a barrier here. We are not going to cross this line. So this is where they kind of get a little weird. Like, everybody else is like, I could shift up and down, but there was no restrictions. And so I want you to put a point. I'm going to do it in a different color than my red. I want you to put a point at 0, 1, and we have to hit that point. And so to the right, we get really, really steep. This is like exponential growth. To the left, we're going to get really, really close to that red line that I drew and not cross it. We're getting really, really close to 0, but we're never going to actually get there. The graphing calculator is going to look like it's touching the x-axis, and it might even look like the graph kind of disappears and blends into the x-axis. But it's getting really, really close, and it does go left forever. So you're like hovering, you're like 0.00000000001. You're like basically at 0, but nope, you're just a tiny bit above it. Okay, so you're never going to cross that axis, that x-axis. All right, domain, you're going left and right forever, so that's okay. But here's the part where it gets a little weird. Range, the lowest point you're going is 0, where that red line is, but you're never going to actually get there. So we have 0, but think of it like an open circle, and that's kind of why I drew like an open line there. We're not going to be able to cross that dashed line, so we're going to put a parenthesis. So you're getting close to 0. You're approaching 0, so it's kind of like that idea of an open circle, but you will never get there. And that's why they're kind of just strange. And then it is going to go up forever to positive infinity. All right, now this is exponential growth the way I drew it. There is exponential decay. We're just going to focus on exponential growth just because there are 2 of them, but really they are related to each other. They're in the same family. All right, so let's go back to the calculator. We're going to go to y equals. I'm going to clear out my x squared, and we're going to do a quadratic, and then we're going to do an exponential. So with the quadratic, we're going to do x squared. So we're going to hit x, and you have 2 options. You can hit the squared button, which is right here, or you can hit the caret button, which is right here, and then that'll pop in an exponent, and then you have to type in 2. I like using the squared button, so that's what I'm going to use. So x squared. And then we're going to hit graph. There it is. Do you see how it's a lot more U-shaped, a lot curvier than our absolute value? And you can even compare them. So let's see, I want to do an x squared and an absolute value. So I'm going to do an alpha F2 absolute value of x, and I'll show you. You see how they look different? A lot of people try to draw them the same. But you also you see the color difference. That's pretty cool too. I like that. All right, so I'm going to go back to y equals. So the blue one is our x squared. If you go to the table, actually, let's do that first. Do you see here? I have for my quadratic in blue, I have the y value. So -3.9, -2.4, -1.1. For my absolute value is in red, -3.3, -2.2, -1.1. So you can see the difference in the points. They just kind of tack on for each graph that you have. So if you're having to compare, oh, do they reach the same lowest value? Well, yeah, they do at 0. They're both at 0, 0, and everything else is bigger than that on both sides. So you can answer questions like that by comparing those graphs. Anyway, let's go back to y equals. I'm going to go ahead and clear out everything because we got our weird function family, the exponential function family. Remember that we had b to the x. Well, b is a number. B is a positive number. B is a positive number that is not 1. So let's do 2. We're going to do 2 to the x. Now, to get the to the x part, you do have to use the caret button. And do you see how it pops that little exponent up? And then that's where we're going to put in our variable. So 2 to the x. And then we're going to graph. And there it is. Now in this one, in the color graph, you can see that it is getting really close to 0, but you can still see it kind of like through the x-axis. If you have one of the ones that we have in the classroom, that's the black and white version, you pretty much just see like this part. You don't see the flat line that's blue to the left of that, and so it looks like it disappears, but it doesn't. Let me show you on the table what it's doing. And sometimes the table is good, sometimes the table cheats. Do you see here, we've got times 10 to the, that's what the E stands for, times 10 to the -7th. That means there's 7 decimal places moves that you have to make in front of that. So that's 0.00000095 something. So it's a really small number as you keep going on. if you went up eventually, you would be able to maybe get it to tell you 0, but probably not. Now, let's say you get a calculator. Let's say you get one of my calculators where, somebody has been sitting there and they do this, and I don't know why, but they'll sit there and they'll hold this thing down the whole entire period, and you're at, negative 1,000, negative something, and you're like, I want to be able to see what's going on at 0. This is way too far away. I'm not holding this button down. You have a couple options. You can go to second window, the table set, and you can tell the table where to start. You can change that to 0, and then now you can go back to the table. Or, and I like to do this especially if somebody else has had the calculator and you are not 100% sure, you're having errors or something like that. I can't help you if your calculator is giving you problems if you are on the EOC. I can't. You also can't get any help during the ACT. So here's what I recommend doing. This is and I have it up on my board if you are in the classroom so you can see it. You reset the calculator. And so you do that by hitting second plus, and you're resetting the memory. So 712 is the number. 712 resets everything, wipes whatever was in y equals out, restabilizes the table. So if it is causing issues, you can always do second plus 712 and reset that calculator, and it will be fresh, brand new fresh. Okay, all right. So we did the 4 that we're going to study. So we're actually going to do a unit on linear. Absolute value is going to make an appearance in there. We have like a big unit on quadratics, and then we have a unit on exponential functions. So we spend a lot of time in those. But we have some other ones that you may run into, and the one that I want to talk about next is the constant function family. And I want you to add that this is part of the linear family. So this is like they are related to each other, but they are a little bit special, so they do kind of get their own subset name. So if I asked you, if I gave you a graph and I asked you if it was linear, you would say yes. But is that its special name for this family? We could go a little bit more special than just linear. Okay, so there's a difference when I say constant versus linear. There is a difference here. All right, so I don't really like using the parent function that goes through 0, 0. I'm going to pick a different function. In this case, I want you to put a point at 0, 6. But we're going to make a nice flat horizontal line all the way left and all the way right. That was not nice and flat. I'm going to fix it. That's a little bit better, but hopefully you get the idea. It's supposed to be nice and flat, nice and horizontal. Okay, that is your constant function. Okay, so you hopefully can see why it's linear, because it does make a straight line, but this is different in that it's flat. There's no increase, decrease. There's no slope to this line. The slope of this line is actually 0. So the equation for this is going to be y equals c, or f of x equals c, where c is a number. Okay, c is a number. So in this case, this is y equals the number that it goes through on the y-axis is 6. So that's its equation. So you're dealing with a variable, but that variable really represents a number. All right, how far left and right? Well, we go negative infinity to positive infinity. And in this case, our range is 6. But because we do have this c value here, and it's not just like we're starting at 0 and it's, could change. It pretty much changes with whatever value c is. We're going to just do our range like this. We're going to do c, and so that's in square brackets. And that's our range. So for this one, y equals 6, we would have a range. Our range would be 6. It would be whatever that number is for the y equals. All right, so that is your constant family. And I don't like to use the one that goes through 0, 0, because then that looks like you've just drawn the x-axis in like a bright color. I want it to kind of stand out for you. All right, let's do, this is number 6, the square root family. And then we'll look at getting some of these in the calculator. And then we'll do 2 more calculator, and we're done. So the square root family has a square root in its equation. Y equals the square root of x, or f of x equals the square root of x. And so it starts at 0, 0. And it kind of looks like a little hill. And it kind of flattens out just a little bit, but it is still kind of going up. So there's a bigger increase kind of at the beginning, and then it kind of increases still, but it's not as big. Okay, so the domain here, the furthest left it's going to go is 0, but it is going to go to the right forever to positive infinity. And infinity gets a parenthesis, 0 gets a bracket. This is going to change if we move our function left and right. So that would change, but there's not really a variable that I could write in there that would change that right now. Let's look at range. So the lowest that we go is 0, and the furthest up we go is infinity. This is also going to change. So because these are very kind of able to be changed quite a bit just by shifting the graph left and up or down and right, I'm changing both the domain and the range. These get asked about quite often. They don't necessarily tell you it's a square root function, so you're not really required to know that. But what they'll do is they will give you a picture of one, and then they will ask you the domain and range. So you couldn't do a negative infinity to positive infinity and get half of it right or something like that. So the square root function is a little bit different. But I do want to show you it is related to one of our main functions. So I'm going to do this part over here. And if you notice, it does look like, I'm going to graph this one, does look like a quadratic. And a quadratic is an x squared. And this is the square root of x. And you guys should be familiar with the inverse of squaring something as taking the square root. But why we only look at part, the top part of our square root function, is because if I try to run the vertical line test, guess what? I have 2 places it crosses, it's no longer a function. But if I get rid of the bottom part, I ignore it, then it's a function. So what we have, they are related to each other. It's like they're cousins. They're closely related, and but they're a little bit different. The graphing calculator does not want to graph things that are not functions. So we can't graph it in one equation by putting in one equation because calculator won't let us, because it wouldn't be a function. Calculator is programmed to only receive functions. Go back to the calculator, and we're going to get our constant, and then I'm going to show you the square root function. So we're going to go back to y equals, and then for the constant function, we're going to pick a number. Now, if you pick a really big number like 12 and graph it, you're not going to be able to see it because you are up above where the graphing calculator is graphing. Okay, so you only see a certain window, and this is usually 10, and this is usually negative 10. So if I pick a number bigger than 10 or smaller than negative 10, I will not see that graph. But let's change it to 2 and graph it. Now I can see it. So because I chose a number between negative 10 and 10, I can now see my graph of my constant function. And then you could just change it to a different number. Now what happens is people go to graph a linear function, y equals x, and instead of x, they put in a number, and then they get this guy. So you have to have a variable in your equation unless you're dealing with a constant function. And a constant function just means it's constantly the same number over and over and over again. This function is 5. If I go to the table and scroll up and down, my y value is always 5. Always, always, always 5. Okay, so it doesn't matter what my x is, I always get the same y value. I think this was in the metamorphosis video, this was the spam function where they were putting in all kinds of different stuff and they were always getting the same thing back out. All right, let's look at the square root function. So I'm going to go in, I'm going to clear this out. The square root, if you notice, right above the squared button, there is a little square root. So it's in blue. So what that means is you have to hit the blue button, the second button, and then the x squared button, and then the square root will pop up. So second, x squared, there's my square root. I have to put something underneath, so I'm going to put in an x, and then now I'm going to graph it. And there is my square root. If you want a table, you can. But notice that you have a lot of decimals, and those are the irrational numbers. We talked about those earlier. Those are the decimals that never end. And when we go to graph some of these things, we want to graph nice numbers, so we're going to pick nice values. So 16.4 is a nice value, 25.5 is a nice value. Those would be hard to graph unless you had a big graph. So 4.2, 9.3, those would be things that were easier to graph because the values are more along the lines of a regular coordinate plane. All right, I have two more to show you, and this one is the cubic family. And the cubic family equation is y equals x cubed. Or again, you can write it as f of x equals x cubed. Remember that f of x and y stand for the same thing. All right, here's your graph. So on 0, 0, you're going to put a point. On the right side, you're going to kind of go up almost like a quadratic does, but the left side's a little bit different. You're going to kind of flip that down and go this way. So there is a cubic graph. And it goes left and right, up and down forever. So it goes left forever to negative infinity, right forever to positive infinity. It's going to be harder to see that because it is going to get really steep kind of close to the ends. It's going to look like it's not moving out, but it is. It's just moving little tiny bits. The range, it's going from negative infinity, it's going down forever, to positive infinity, it's going up forever. So there's your cubic function family, and how you know it's a cubic is it's got an x to the third power, x cubed. So notice that the exponent changes the family. So x to the first power was linear, x to the second power is quadratic, x to the third power is cubic. And there are others. There's an x to the fourth power, an x to the fifth power. We actually saw an x to the fourth power in the last one. Remember that W graph? That was an x to the fourth power. All right, let's look at our last one, cubic root. And there is a relationship between cubic and cubic root. And when you do a cubic root, it's almost like you draw a square root, but you put a little 3 in there to represent the cubic root. And then you got to put your x. Or we do f of x equals the cubic root of x. Now remember, if you're taking notes on this and you're writing these down, you can use them on your tests and your quizzes. All right, so I'm going to start at 0, 0. I'm going to kind of do like a square root function on one side. It's a little bit narrower, but it's okay if you don't. It's the basic shape. And then on the left, we're going to do the same kind of thing, but we're going to go below. And so it kind of looks almost like an S that got pulled, or I like to think of it as like helicopter blades. We're missing a couple, but looks like that. All right, and this one goes left forever, right forever, up forever, down forever. So this is going from negative infinity to positive infinity, and the range is from negative infinity to positive infinity. And so that is true for every single cubic root function. So if you're having to do domain and range for these functions, the ones that have the stars are the ones you have to really pay attention to. I starred them. The rest of them, They should fit no matter what cubic root function or quadratic function or constant function or linear function, doesn't matter. The domain and the range aren't going to change if those are not starred. All right, so these are, and let me just show you here, the cubic family. I'm going to move this, do it in blue. It's not at 0, 0, but do you see how it looks very similar to the cubic root? Again, it's an inverse. They have an inverse relationship. This is x cubed. How do you undo a cube? You take the cubic root, and vice versa. Okay, so they are related to each other, and they get confused sometimes. So you need to make sure that you know that the root looks like it's laying down. The root looks like it's being a little lazy. And that's what it looks like to me. Looks like it's taking a nap, whereas the quadratic and the cubic functions are, standing straight up. They're going up and down, or just both up or both down. And we'll talk about changing these guys a little bit. But let's look at the graphing calculator one more time, and then I'm going to tell you about this. All right, so graphing calculator, go back to y equals. We're going to clear it out. We're going to do the cubic function, which is going to need an x, and then we're going to do the to the third power. So we've got our caret, which I always say is to the, and then third. So now we'll graph it. Here's your cubic function, and you can go to the table, scroll up, scroll down. The numbers get pretty big pretty fast, pretty small pretty fast. So that's your cubic function. And then, so y equals, clear that out. Then we're going to go to, I think we can go in the alpha window. Yeah, you want to hit the alpha window and then go down to 6. Now there's a little X in the actual instructions, but what that does is it gives you a place to stick this. Sometimes people try to do like a power and a square root. That doesn't work. So 3, and then we're going to put an X for our cubic root. There she is. There's the table if you needed it, where they're taking the cubic root values. Okay, so you should be, and I touched my microphone. So you should be playing around with the graphing calculator. As we get more and more into the functions, you want to get more and more used to putting things into the graphing calculator to explore what's going on. You can look at pictures, you can compare things, and if you're not using the graphing calculator, you're not pressing the buttons, you're not looking at the pictures, you're not getting used to this. Even if it's the virtual one, you're not getting used to it. You're only doing yourself a disservice, because then when we come back, you're going to have some issues with being behind with your graphing calculator. So play around with it, play around with y equals, go back, look at your notes, try to type in equations, look at pictures, all of that good stuff. Now let's talk for the very end about this. You will have a quiz. It is a matching quiz. It looks pretty much like this, some version of this. It will have pictures, it will have equations, it will have family function names. I'm not going to give this quiz virtually through Canvas. This is a quiz that I don't want you looking at notes for at all. And so if we come back, we will take one. I will let you know when that's happening. But in this video that I'm making today, the school board's actually going to meet. It's Thursday right now. The school board's meeting tonight, and we'll find out what they want us to do. So if we're coming back soon, you will be taking this quiz soon. If we're not coming back soon, or we never come back, then you'll never take this quiz. But it doesn't mean that it's not good to know these things, because A and B and C and D and E and G and H, all of those are things that you're going to use in Algebra 2, in pre-cal, in calculus. You will be expected to know them and more. So if you choose not to learn their names or learn their equations or learn things about them, you're only setting yourself up for failure or hard times later. So I recommend you can go and pause the video and try to fill these out yourself. Or you can go to the slideshow and try to do it yourself. If you want me to check your answers, I can. You can just email it to me and see how you're doing. You can go back and check your notes and see if you got them right. But you will not be taking this quiz unless you're in the classroom. And do not be surprised if I make a video and we're coming back the next week, and the very first thing I do is hand you one of these papers and say, here you go, take this quiz. Do not be surprised. If you are not watching videos, you're probably not hearing this. But if you're not watching videos all the way through and you're not hearing this, then you're going to have some issues. All right. I do have a video that I made today. I'll go ahead and tell you about. I made a video on how to get to my classroom from the front of the building. So if we are coming back, you will be sent an announcement or an email or something like that with a link to that video so that you can watch, see how to get to my room so that you can know where you're going, at least when it comes to math and maybe a couple other places. I tried to point some different things out. And I walked around the room. It's a little messy right now, but it's not too bad. All right, I will see you guys in the next video. Have a great weekend. It is a long weekend, so I'm not going to have anything up for you on Monday, but you can use it as catch-up day. So if you were behind, you need to get caught up. All right, have a great long weekend. I'll see you next week. Bye.